Good morning, friends. Today we are going to elaborate Unit 5th Part 1. Topic is Hidden Lines and Curves Back Face Detection. This video is sponsored by Shri Ram Murthy Smarak College of Engineering, Technology and Research, Bareilly, and presented by Sachin Kumar Saxena, Assistant Professor, CSE Department, SRMS College, Research. Unit 5th says we are having two sections in Unit 5th. First is hidden lines and surface. Second is basic elimination models. In the hidden lines, we are having several surfaces which is having base, back face detection algorithm, depth buffer method, a buffer method, scan line. But in the second part we are having basic elimination models, that is ambient line, diffuse reflection, specular reflection, Fonch model, combined approach, Van model, intensity attenuation, color consideration, transparency and shadows. A buffer method, scanline method, all these are the topics in Unit 5th. We will cover one by one, but before that they have described there are two sections of Unit 5th. Therefore they have written here. So first and foremost we read what are hidden surfaces. When we view a picture containing non-transparent objects and surfaces, then we can't see those objects from view which are behind from the objects closer to eye. We must remove these hidden line surfaces to get realistic screen images. The identification and removal of these surfaces is called hidden surface problem, because the image can have one or more images, one or more lines, one or more structures which are hidden behind the actual picture. Now we view a picture containing non-transparent objects which is opaque in nature, which are not transparent. So then we can't see those objects from view. So from view we cannot see very clearly, or we cannot have vivid structure of such kind of objects. So as it is depicted in the figure, that no lines removed in this figure, we are having cone which is having certain radius on the bottom side. We are having this cube which is having dimension A, B, C, length, breadth and height. We are having certain circle and followed by 3D circle which is having diameter on the bottom and upper floor also. All these articles are resided on the table and are equipped or settled on a table. So this is called wireframe, because no hidden layers are escaped, no lines are hidden behind the scene. Now from the previous figure they have hide the figures from the certain images. Now the cones is not having the hidden layers, cube which is the layers which are hidden from backward, foreground lines still we are having, but background lines we are missing. So we have hidden the background lines. Similarly in the upper and bottom circle they have hide the circle. and they have hide the lines, those are hidden inside the architecture. So these 3D architectures are hidden behind the material and behind box. So this is the color representation. The cone is colored with the yellow, cube is colored with the red, and the hole is colored with the transparent background. So they have not shown any hidden layers or any hidden lines, any hidden colors. So in order to hide hidden surface removed. So this picture shows hidden surface removed from all these three objects. Because we are studying 3D objects since unit 3rd, we have moved to unit 3D object. So therefore they have moved to objects. Now what are the visual surface detection? Visible surface detection or hidden surface removal can be understood in various ways. In order to hide the lines which are situated in the backward, realistic scenes, closure objects occludes the others, because we are having certain scenes and certain objects also. So classification says object space methods and image space methods. So using these two methods we can hide the lines. So object is what we are having in the 3D, which can be viewed from various ways, various angles, various parts, and image which is in the 2D dimension. As we study in the projection part, how we can convert projection in order to convert 3D to 2D dimension. So there are two types of methods, object space and image space. So visual surface detection can be found in various. Object space method says algorithm to determine which parts of the shapes are to be rendered in 3D coordinates. Methods based on comparison of objects for their 3D positions and dimensions with respect to viewing positions, efficient for a smaller number of objects but difficult to implement. We are having so many objects which are defined in the 3D space, so their position and dimensions can be defined in various ways, sufficient for a small number of objects but difficult to implement, because they are very difficult to show on pen and paper. Depth sorting, area subdivision methods. Depth sorting, what is the depth of the image, what is the differentiate between foreground to background, is defined in the area subdivision method. So this is defined in the various ways. The 3D coordinates also maintain the object of the certain. Now after the object space methods, which is defined in the 3D objectives or 3D dimensions, or in the certain part, we are having image space method based on the pixels, which is the unit part of the image to be drawn on 3D. As I have already said that the image is described in the 2D dimension, whereas object can be described in 3D space also. So try to determine which object should contribute to that pixel. Running time complexity is the number of pixels times number of objects. The number of objects is having how many pixels are the time complexity. Space complexity is 2 times the number of pixels. The number of pixels and the space complexity is having certain relationships, because we are having one array of pixels for the frame buffer and one array of pixels for the depth buffer. In order to store the information, in order to store the value, so we are having certain pixel values. So now we are having coherence properties of surface coherence properties of surface can be determined in various methods, various ways, because it is used depth buffer and ray casting methods. So depth buffer says the image space method, which is defined in the various dimensions, one array of pixels for the buffer and one array of pixels for the depth buffer. So it is ray casting methods which is defined previously. Now from the defined figure we are having color image and we are having black and white image. Both are not having the hidden lines. So hidden surfaces are not removed but displayed with different effects such as intensity, color or shadow for giving hint for third dimension of the object. Simplest solution use different colors, intensity. So we are having simple solution. Hidden surfaces are not removed but displayed with different effects, because intensity depends upon the intensity affects the number of pixels inside the image. So if intensity differs, so the pixel value will differ. The color also having number of pixels at each value, so number of pixels will be affected by color or shadow of the image. If it is grayscale level, so it is the grayscale level, then it is the low scale. So hidden surface elimination or visible surface detection. When we view a picture containing non-transparent objects or surface, then we cannot see those objects from view which are behind other objects. So we cannot have very clear objection or very clear perception about the figures, because there is a certain lines and there is a certain area which can be described behind the scene. So in order to fulfill that condition, we must remove hidden surfaces to get a realistic screen image. At least we are understanding what the image is. The identification and removal of these surfaces is called hidden surface elimination. So randomly we are not removing any figure or any dimensions, although we are having certain methods, certain procedure to hide the surface, or we need to identify those parts of a screen that are visible from a chosen viewing position. So from which point we are viewing the object, from which angle we are projecting the certain elements. Visible surface detection. What are the visible surface detection? These are the key points of any hidden surface elimination methods. So procedure is also identification and removal for the certain values. So this values is having hidden surface elimination, which cannot remove the lines which is not realistic, which is not projected on the screen image. Then only we view a picture containing non-transparent objects. Hidden surface elimination or visible surface detection. This detection, why detection? Because the objects or the position which are behind the scene is resided or the situated before the surface, because it is the surface which cannot be hid. So one of the most challenging problems in computer graphics is the removal of hidden parts from images of solid objects. In real life, the opaque material of these objects construct the light rays from hidden parts and prevents us from seeing them. In the computer generation, no such automatic elimination takes place when objects are projected onto the screen coordinate system. Instead, all parts of every object, including many parts that should be invisible, are displayed. So there are two methods of it for doing such kind of elimination: object space methods and image space method. The algorithm operates on different kinds of scene models, generate various forms of output, or cater to image of different complexity. All use some form of geometric sorting to distinguish visible parts of objects from those that are hidden, just as alphabetical sorting is used to differentiate words near the beginning of the alphabet from those near the ends. Geometric sorting locates objects that lie near the observer and are therefore visible. Hidden line and hidden surface algorithm capitalize on various forms of coherence to reduce the computing required to generate an image. Different types of coherence are related to different forms of order or regularity in the image. The scan line coherence arise because the displays of a scan line in a raster image is usually very smaller to the display of the preceding scan line. Frame coherence is a sequence of image designed to show motion recognition that successive frames are very similar. Object coherence results from relationships between different objects or between separate parts of the same objects. A hidden surface algorithm is generally designed to exploit one or more of these coherence properties to increase efficiency. Hidden surface algorithm bears a strong resemblance to two-dimensional scan conversions. One is object space method, second is image space method. Object space methods: in this method, various parts of objects are compared. After comparison, visible, invisible, or hardly visible surface is determined. These methods generally decide visible surface in the wireframe model, that these are used to determine a visible line. So these algorithms are line based instead of surface based. Method proceeds by determination of parts of an object whose view is obstructed by other object and draws these parts in the same color. So hidden space surface elimination or visible surface detection construct two different, because first is object space method. In this method, various parts of objects are compared. After comparison, visible, invisible, or hardly visible surface is determined. These methods generally decide visible surface. In the wireframe model, these are used to determine a visible line, so these algorithms are line based instead of surface based. Method proceeds by determination of parts of an object whose view is obstructed by other object and draws these parts in the same color. In the image space method, here positions of various pixels are determined. It is used to locate the visible surface instead of a visible line. Each line is detected for its visible. If a point is visible, then the pixel is on, otherwise off. So the object close to the viewer that is pierced by a projector through a pixel is determined. That pixel is drawn is appropriate color. These methods are also called a visible surface determination or detection. The implementation of these methods on a computer require a lot of processing time and processing power of the computer. Backface detection algorithm object space method. A fast and simple object space method for identifying the backfaces of polyhedron is based on the inside-outside test. A point xyz is inside a polygon surface with plane parameters a, b, c and d if a, x, b, x, c, z plus d is less than 0, where coefficients a, b, c and d are constants describing the spatial properties of the plane. The image space method requires more computation. Each object is defined clearly. Visibility of each object surface is also determined. There are certain differentiation between object space and image space method. In the object space method, image space is object based. It concentrates on geometric relation among objects in the scene. In the object space, here surface visibility is determined. In the object space method, it is performed at the precision with which each object is defined. No resolution is considered. Whereas in the image space method, it is a pixel based method. It is concerned with the final image, what is visible within each raster pixel. Here, line visibility or point visibility is determined. It is performed using the resolution of the display device. In the image space method, calculations are resolution based, so the change is difficult to adjust. In the backface detection algorithm, we can simplify this test by considering the normal vector n, capital N, to a polygon surface which has Cartesian components a, b, c. In general, v is a vector in the viewing direction from the eye or camera position. Then this polygon is a backface. If v into n is greater than 0, then we can say vector v in the viewing direction and a backface normal vector capital N of a polyhedron. This figure, which is shown in like pyramid, is called polyhedron, and the viewing position is described from vector v. Vector display used for object method has large address space. Object precision is used for application where speed is required. It requires a lot of calculations if the image is to enlarge. If the number of objects in the scene increases, computation time also increases. They are suitable for application where accuracy is required. Image can be enlarged without losing accuracy. In this method, complexity increases the complexity of visible parts. So there are certain differentiation between object space and image space and backface detection algorithm also. Backface detection, also known as plane equation method, is an object space method in which objects and parts of objects are compared to find out the visible surfaces. Let us consider a triangular surface that whose visibility needs to decide. The idea is to check if the triangle will be facing away from the viewer or not. If it does so, discard it for the current frame and move on to the next one. Each surface has a normal vector. If the normal vector is pointing in the direction of the center of projection, then it is a front face and can be seen by the viewer. If this normal vector is pointing away from the center of the projection, then it is back face and cannot seen by the viewer. Furthermore, if object descriptions are converted to projection coordinates and your viewing direction is parallel to viewing z-axis, then v is equal to 0, 0 vz and v into n is equal to vz c. So the back face detection method is very simple. For the left-handed system, if the z component of normal vector is positive, then it is back face. If the z component of the vector is negative, then it is a front face. Thus, for the right-handed system, if the z component of the normal vector is negative, then it is a back face. If the z component of the vector is positive, then it is front face. Back face detection can identify all the hidden surface in a scene that contain non-overlapping convex polyhedra, recalling the polygon surface equation. While determining whether a surface is back face or front face, also consider the viewing direction. The normal of the surface is given by a polygon is a back face if we view n is greater than 0, but it should be kept in mind that after application of the viewing transformation, viewer is looking down the negative z-axis. Therefore, a polygon is back face if viewer will also be unable to see surface with c is equal to 0. Therefore, identifying a polygon surface as a back face if c is less than or equal to 0. The limitations for back face detection algorithm are: this method works fine for convex polyhedra but not necessary for concave polyhedra. We have already studied differentiation between convex and concave polyhedra or polygons. Method can only be used on solid objects modeled as a polygon mesh. Back face detection algorithm in a right hand viewing system with viewing direction along the negative z v axis, the polygon is a back face if c is less than 0. Thus, in general, we can label any polygon as a back face if its normal vector, then z component value is 0. So c is less than and equal to 0. So when we project 3D objects on a 2D screen, we need to detect the faces that are hidden in 2D. Backface detection also detect a fast and simple object space method for locating back faces. A point xyz is inside a polygon surface with plane parameters a, b, c, d if ax plus by plus cz plus d is less than 0. Problem: given a scene and a projection that can we see is a problem because we cannot have the surface. It is used to plot only which will face the camera. The objects on the back side are not visible. This method will remove 50% of the polygon from the scene if the parallel projection is used. If the perspective projection is used, then more than 50% of the invisible area will be removed. The object is nearer to the center of the projection. Number of polygons from the back will be removed. It applies to individual objects. It does not consider the interaction between various objects. Many polygons are obscured by front faces, although they are closer to viewer So for removing such faces, back face removal algorithm is used. So we have two main types of algorithm. Object space is determine which part of object are visible, also called a word coordinates. Image space determines per pixel which point of an object is visible, also called as screen coordinates. Two main hidden surface removal algorithm technique can be described. Object space hidden surface removal for all subjects. Image space 3D clipping transform to screen coordinates, hidden surface removal, and so on. When the projection is taken, any projector ray from the center of projection through viewing screen to object pieces object at 2 points. One is visible front face surface and another is not visible back face surface. Any query? For more information, we have studied till now. This algorithm acts as a pre-processing step for another program. Another algorithm. The backface algorithm can be represented geometrical. Each polygon has surface vertex. All vertex are numbered in clockwise because it is a simple and straightforward method which is used to remove the hidden lines. It reduces the size of database because no need to store all surfaces in the database. Only the visible surface is stored. In the backface removed algorithm, we repeat polygons in the scene and we are having number of hidden algorithm, which is in the next slide we will see depth buffer algorithm, which is simplest image space algorithm. For more inquiry, we are having our own blog sachinplacement.blogspot.com, or you can mail me at sachin.saxena@srms.ac.in. This is official email ID and the blog where you can have not only from computer graphics handwritten notes, previous question papers, quiz, etc., but also other subjects like principle of programming language, image processing, DA, data structure, etc. Thank you very much. Thanks for today.